What up, Facebook, YouTube, Twitter, Instagram, SoundCloud, SoundClick, and all points Space Shuttle. I'm going to talk way out of my scientific element because, one, I'm not a scientist, but I, like most people, are interested in science because once you start digging into things, it's like, wow, that can really happen or that did really happen. And but I'm going to be way out of my element. But I'm doing this because I'm curious to what everybody else thinks. Okay, so there's been 3 space shuttle accidents. One of them, was just a test where basically a fire happened and the inside of it burned up. You know, and the 3 astronauts, rest in peace, were burned up inside of it, and the other one was the Columbia and the Challenger. Now, forgive me if I get any of the facts wrong. Okay, I'm not an aficionado. The purpose of this video is not to show what I know. It's to simply bring a conversation to the table, and hopefully a scientist or somebody who is a lot more versed in science can explain to us, the average people, and myself, why things happen. And then I like to throw in my theory. So, okay, so one of the space shuttles blew up when it came in, and that was the Columbia. It was coming in. They were talking to NASA. Next thing you know, boom. That space shuttle blew up because of the metal that's protecting them from the heat shields. There was, I guess, a space in between them, and or a crack that had happened in the bottom of the heat shield, and that crack had happened because of what the elements that they were using like a foam. And as you can see in one of the space shuttle crashes, how some of it was breaking off. And this had happened in a space shuttle when they went into space before the Columbia and the Challenger had happened. They had noticed that whatever this is breaking off and it's hitting the heat shields. So they surmised that this was the reason why this happened, and they tried to use foam, but they was using something else. But then they tried to use like this foam stuff because it was less expensive. You got to understand, the space shuttle had been cutting their expenses, and they had cut the amount of people who were working in the space programs, and they went, instead of government, they went private, and we're trying to pretty much cut the cost of going into space. And I just want for you guys who are listening to this, to keep that in mind. So we have some elements here that I want to touch on. One, the cost of the space program is magnanimous. The other one, the accident that happened, and the reason why it happened was because they cut the cost, they used a cheaper material, boom, people died. And then the way people died, heat. The heat shields were severed, and then boom, all at once it just went up, because it's a lot of heat when you're descending back into the atmosphere, and they needed every bit of those heat shields. So keep that in mind. Okay, so I'm going to talk about what I think might help the space program, and just a theory of what I think, or why can't we do this type of thing. For one, we have the problem of heat itself. When an object is moving at a high rate of speed, of course it causes friction, especially when you're coming back into the atmosphere. Boom, you have your heat. The heat is a problem. Now, in the and I'm going somewhere with this. And in the Challenger, when the Challenger went up, they went to fire the rockets, and when they fired the rockets, the whole thing just disintegrated in front of all of the entire world, actually. So they went to fire the rockets to give them the extra boost, and then boom, the whole thing went up and out. Okay, so and that was because of the fuel, of how much fuel was on there. So the fuel blew up, and it blew the whole ship up. Now there are safety protocols so the ship where the people are, that for that not to happen. But there is so much fuel there. Remind, this is another problem: the fuel itself, the cost of the fuel, and what fuel they're using. But there's so much fuel there that it blew up everything. There was not a chance. They couldn't even separate what was the part where the cab, where the people were in, and what was the rest of it. It was all blown up. That's another issue. So we have the heat issue, we have the fuel issue, we have heat coming from speed. When you're descending, it's the speed of the descent that causes the heat and the the rotational pull, so on and so forth. But the speed of the descent is causing the friction, and of course, just gravity itself. And when you look at that, okay, so when you look at that, and you look at recently, there was a guy who went up 2 miles and then he fell, to the earth, pulled a parachute, and everybody saw that video. Very, very nicely done, very scary as heck, but nonetheless, when he descended, he didn't descend in a ball of fire. He was moving pretty, of course, at as fast as anyone could fall. I forgot what that descent is called, but nonetheless, he wasn't on fire or anything like that. The gravity wasn't, So, when I look at stuff like that, I'm thinking, well, once the Challenger gets in again, I'm not a scientist. Once the Challenger got into, was not the Challenger, but the Columbia got into the Earth's atmosphere, it was still moving at a high rate of speed. Nonetheless, the heat still caused a problem. And then I started thinking, what if we took away some of the elements of these explosions and really looked at it? Like, what if we took away the fact that the descent of a space shuttle has to move at a certain speed just to break into the atmosphere? It has to do that. There has to be, there's a scientific and a mathematical equation that gets you to come into the Earth on its curve and land you where you want to be, pretty much. But you have to know those numbers in order to be able to, come in at a certain rate of speed. But I was like, the Earth is spinning at a high rate of speed. We know this. We know that once you're coming into the gravitational pull of the Earth, you're going to get hit with a wall of friction into stratosphere, atmosphere, biosphere, whatever sphere it is, and boom, you have to come. You don't come like this. You actually come in like this. So it's an angle, and one of you, 5.10 GPA guys are going to start breaking this down to me, and that's what I want. But nonetheless, I was thinking, once you get past gravity, or even calculate for gravity, like, why does it have to be where you have to move at a certain speed? And I was always thinking that, why are we moving, trying to compensate for speed? Why do we have to move so fast? And then once we even get in the atmosphere, we're still moving at a high rate of speed, and it still causes, the vehicles to either break apart, the shudder, or the friction, so on and so forth. And I said, there's something to this. Now, I saw a video where they were talking about an ancient race that lived in the water, and one person said that they saw a vehicle go into the water, and when it went into the water, it was still, moving at a high rate of speed, as if the water didn't even stop it. And I thought about the water as gravity. Like, once you hit that wall of water, there's gonna be a break. Everything does it. and then it's going to continue at a certain rate of speed. But they said this thing kept going as if the water wasn't around it. And it just made me think, okay, so you got the issue of speed, you got the issue of heat, you got the issue of money because we're using less expensive material. And I'm thinking, well, you can cut out and you got your issue of fuel. Well, I'm thinking, I know I'm rambling, but I'm going somewhere with this. But I'm thinking we could probably cut out the fuel, cut out the heat, cut out the speed, and the money is always going to be a factor. But nonetheless, it'll be cheaper if you. And here's what I was thinking: some people are trying to build anti-gravity machines, and so one of them was using liquid and a certain type of liquid that spins, at like 10,000 RPMs, and is just ridiculous speed, and eventually that's how UFOs fly. And I was thinking, space itself, Earth rotation has a number. So if Earth rotation has a number, then what is outside of it is also a calculable number. And what I'm thinking is space itself is a calculable number. So what is the material of space? And people are going to say, well, it's just a void. And I'm like, well, what is a void? What is the material of a void? What is the calculated equality of a void? Why can't we calculate a void and create a void? And some people say, well, we have created a void or weightlessness, but we have not created space. Now, somebody is probably going to know more than me. So I'm thinking, instead of us going to space and shooting our big engines and trying to break out into the atmosphere, what if we bring the atmosphere to the vehicle? Now, like I said, this is going to be asinine, but it's just a theory. What if we had and I call it a pulse engine, and the reason why I call it this engine, a pulse engine, because it's kind of like emitting an electromagnetic pulse. Only it's going to emit it's going to emit a atmosphere changing material that covers the circumference of the object that it is within. So it will create space within. So it'll create space within. Oh, let me use a bigger one. Okay. My phone is a so-called rocket ship, except it's not going like this. It's ascending like this. But the engine inside of it is emitting at a high rate of speed is emitting a signal, a frequency, or whatever it is that is covering on all points the circumference of the ship, and it's allowing it to manipulate the atmosphere or gravity around us. That's what would happen if we took some space, outer space, and put it somewhere here on Earth, and we say we had it in the shape of a ball. Well, whatever is inside of that ball is going to be a void, a vacuum. It's going to be weightless. You're not going to be able to breathe in it. Well, if we took that same material and that same property and we said, okay, we built a machine or a engine that emits that space material to only surround the circumference of a vehicle, then that vehicle would no longer be held in the same responsible properties as every other vehicle. So if you had this vehicle that had that type of engine, and then you had another vehicle that didn't have that type of engine, when this vehicle is moving, it's going to have friction. When the other vehicle is moving, there'll be no friction. That vehicle can move up, down, left, right, wherever it wants to go with no friction at whatever speed it wants to go. And the engine will probably be quieter and it will cost less than fuel. There will be no need for it to move at a certain rate of speed because once it ascends, it can ascend with pretty much no problem. And once it descends, it can come right into the atmosphere because it will be like space. It will be like space is around this, and it will just sit right down. It'll fall 2 miles and sit right down like a feather. So this is just, I don't know. A lot of people have thought about this. You've seen this in a lot of futuristic movies and whatnot. But I was just thinking about why can't we develop an engine that does that? And I'm not a scientist, so I can't help you. I'm just a guy who says, why can't we do this? So I don't know. Somebody get back at me. But I know that if you did have something that had those properties, then it would eliminate every single problem that you had. It would cut down on the cost, not unless the engine was a ridiculous cost, but I'm sure we can always do something about that. It will cut down on your costs. You would have the choice to use it. It would be like using a hybrid vehicle. You'd be like, okay, well, I don't want to use electricity. Now I'll use gas. So once you're in Earth's atmosphere, you can use a regular engine. You don't always have to use that engine. So also, it would take care of your financial cost once the market is everybody has it in the market, because we know how that goes. When a few people have it, the cost is up. When everybody have it, the cost goes down. So the cost will not be a factor so much after a while. The heat will be no factor whatsoever because there will be no heat involved. There will be no heat, probably very little sound. The weather, you won't have to wait. We had in one incident was because it was cold. We do not have to worry about the weather. There will be no issue with the weather at all. It could be freezing cold or be as hot as, as the Sahara. It just wouldn't matter because the atmosphere around the ship, would be like space. And I don't mean around the ship as in here's the ship and then there's this big bubble around it. I mean it is around the ship. It only emits the pulse around. That was graceful. Only emits the pulse around the ship. And of course, the inside would still have the same properties of, you need oxygen and so on and so forth until you cut the engine off, that type of thing. But so it would cut out your heat. It would cut out your money problem. It would cut out your speed problem. And yeah, I don't know. It's just a thought. Somebody tell me what you think. It's your boy Tone 202. Peace.